Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Welcome to the open conversation at the International Conference on Advancement in Data Science, Learning and Adaptation System, Challenge 2026. My name is Widia, and I'm here on serve of the moderator for this session. So today we have various remarkable presentations explore the subtopic about the advance in large language model, species language model, and so before we begin, we want to outline for conversation, and each presenter will have 2 minutes for presentations, and we'll operate our 2 minutes left at the 10 minutes. I will set the next up here. And also we will follow the 5 minutes for the question and answer. So I kindly ask all the minutes for a question until the end as a presentation. So if any presenter is not ready, then 5 minutes, this schedule time, we will process the next person. The presenter who has not ready will be rescheduled to present the session. So yeah, please enter the stage rooms. And the first presenter from Mr. M.Kom. Yeah. So without further ado, Mr. M.Kom, the president, the Department of Ecology from Strategy for Particular Language Model in Indonesian Historic Direction. So please join me. Welcome to Mr. M.Kom.
Assalamualaikum warahmatullahi wabarakatuh. Okay, so yeah, I want to present my work. So this work is a collaboration with my university, that's one of the Sumatera, and then from the University and also from the Universitas Gajah Mada. The title is Evaluating from Strategies for Multimodal Large Language Models in Indonesian Misogynistic News Detection. Next. Next. Okay, so misogyny. What is misogyny? So misogyny, maybe we be more familiar with hate speech, but misogyny is hate speech which the target is specifically women. And before misogyny content usually in textual data, but since social media shift from textual to more visual, now misogyny also happen in memes. So here we focus on misogynistic memes on social media. So because it's memes, the data will become multimodal, and this multimodality change or post growing. Post multimodal. This data easily deceive standard textual moderation system, which means the automatic detection of this kind of head speech is more challenging. And also there is a scarcity or no data set on multimodal misogyny in Indonesia. Next. So here we try to address two research gaps. First one, the most of automated misogyny detection focus on textual, but since the social media shift to more visual, the misogyny data set on multimodal in Indonesia still not exist. But we know that there are also some data sets of multimodal or misogyny in other languages, such as English or also I think hot mix in the English, also in I think in Italy. And then for the Indonesian context, yeah, in Indonesia, it means usually also put in local idioms, sarcasm, and also regional cultural differences, which makes the automatic relation more and more challenging. Next. So our first conclusion, so we try to build our own data set, I mean new data set for vertical model misogyny, which means memes. So here we try to collect the data set from Facebook forums, and here our collection consists of 628 data, which consists of 278, which means misogynistic, and 421 not hate, not misogynistic names. And we manually annotated these names by using manual annotation. Next. So this is the process of building process of the data sets. We start with crawling, so we take the data from Facebook forum for several images there, and then we try to filter and we isolated means specifically referencing to women-related themes because we focus on misogynistic, which means specifically targeting women. And then we do some language filtering. So we only take the memes which contain Indonesia. So we exclude the memes which contain language other than yeah. And then lastly, we conduct the manual annotation, which here we use male and female annotator, one male and one female, and then if there is a disagreement, we ask annotators to discuss and achieve the agreement. Thanks. So during the annotation process, we found several findings. So we found that memes, specifically in Indonesia, really heavily on these cultural references that may not be universally accessible to all demographic groups. And then based on our annotation process, we obtained Cohen Kappa 0.5 for indicating moderate agreement and initial disagreement were successfully resolved. We have structured discussion. So we asked the two annotators to discuss, and we after the discussion, they will reach the agreement for the final label between misogyny or misogynistic. And this process emphasizes the subjective nature of offense and harm in gender-based digital discourse. Since this is the subjective task, yeah, the annotation process is more challenging than annotating the type. Maybe if you are more familiar with sentiment, it's already challenging. But since this is specific and usually also very subjective to the annotator, it's more challenging. That's why the content kappa here for the initial annotation 0.5 for which is moderate. Next. So after we build dataset, since our initial dataset is more or less 628, it's still small. So we think that maybe it's not feasible to train and test to separate the data into train and test set. So first we will have experiment by using multi-modal large language model. And we try to use several models start from Gemini and GPT, which is maybe we familiar with it, which is we need to if we this is the high end, we call it high end because it's very big. I think the last one is very big. And then we also use open weight, which is open source, and the model is not as big as the high end model. We use Kema 3. And then we also use we also try to use the more compact version of LLM, Here we use when 2.5 VL and also lava condition. Next. And for the prompting, we try to experiment with several prompting strategies. Like when we try to prompt in like in ChatGPT, usually we need to have some strategy to make the LLM give us the best response as we expected. So here we try several strategies. The first one, zero prompting, which is the most the simplest one. So here the best case where the model was instructed to classify the memes as hate or not hate without providing any example. So like when we simple prompt, like we ask the LLM to classify which this data is hate or not. And then the second one, offering rewards. So here we will have some kind of a scenario. So this prompt built on zero shot, based on the zero shot instruction, but we add behavioral framing by offering virtual reward and penalties for correct and incorrect answer for the LLM. And then the third one, flattering the classifier. Here the prompt include explicit praise of the model's capability. Like for example, you are highly accurate and reliable. So like we praise the machine to frame the model positively based on the psychological framing literature that we have. And then the fourth strategy, refusal suppression. So here, instruction tool model often programmed to avoid engaging with potentially harmful or sensitive content. So, for example, when we use a ChatGPT, when we ask them to produce harmful content, usually they will refuse. So we try to include instruction in prompt explicitly, telling the model to not to respond with disclaimer or refusal statement. And then the last one, this is also the basic one shot prompting. So here we will provide the model MLM with two examples. The first example is the head example, and the second example is the not head example. Next. From the result, so yeah, this is the result of best. So we only here we only present the best number of score by each model, which we use the GPT 4.0, 4.0, and then GPT 2.5, Gamma, Web, and Lava. So if we take a look for the high-end model like the Gemini and ChatGPT, the zero shot provide the best result, which means 0.763 or 0.46. So it means that for the high-end model, maybe they already trained by a lot of data, the capability is already enough to classify. But for the smaller model, like a Gamma, Quent, and even for the smaller one, Quent and Lava, we can see that for Gamma, one shot improve provide the best result. And our prompt strategy works when we experiment with the small model like a Quent and Lava. Thanks. And performance across the prompting strategy from this, we see that GPT and Gemini achieve the highest score consistently. Zero shot, and we see that zero shot obtain the best overall performance. And then for a smaller model, show a weaker visual listening natively. For example, Gamma demonstrated a significant performance leap or improvement when assisted by example for short prompting. Next. Conclusion. So yeah, since this is the first step of the study, this vision is means so this study less network or inclusive multimodal text speech because now we work with multimodal data. And for the future work, well, from such engineering set like with the feedback tool, high capacity multilingual model remain absolutely crucial for untangling complex sociocultural nuances and identifying the
Thank you very much. Okay. So we move to the next session. It's about the Q&A. So, any question for Mr. Ethan?
Maybe I have a question. Okay, because I'm coming late here, actually, how should I ask the name? Oh, okay, Mr. Renda. Okay, nice to meet you, Mr. Renda. My name is Febriyani from Universitas Indonesia. So, yeah, my paper that I submitted is about LLM2. So, but in this case, I just want to know that what temperature did you use for this kind of test? The temperature parameter, yeah, it's between 0 until 1, right? Because like for 0, in my case, because this is a strict test, so I put the temperature for 0 and 0.2. But for this kind of test, yeah, which how much do you put the temperature inside? 0. Also 0. Okay. Also, this is just one thing that because I just have presented my thesis papers yesterday also, and the examiner is also yeah, because not about the what the temperature, but do you do several SEM testing for the same case? Because in LLM, he said that yeah, sometimes even with 0 temperature, it could be different. Right? So like in your case, I just want to know that is it that's different even we put the temperature to 0, or usually the output is still
Actually, we only run by temperature 0 and we run 1 night.
still on time. Yeah, okay. Okay, okay. Because you said that maybe it could be different, but also I still want to try to test also the, but yeah, we will see what the others. Okay, thank you very much for that.
Okay, now we talk about temperature.
Yeah, yeah.
So, from my perspective, the temperature of CO is more
Yes. Still, oh,
not more realistic like temperature one.
yeah, so
Yeah, so we try to temperature here because it's more not more reactive. So the output is not fine.
yes,
It's test. So yes, we using 0.
but yeah, the question is because that's the our assumption, right? That we don't know that.
Zero temperature, maybe
That's
still when we test again, the result may be different.
yeah, maybe, but yeah.
A bit more
Just
than
Okay, okay.
Okay, thank you very much. And the discussion, yeah?
Yeah.
After this session, maybe you can discuss with Mr. Enan. So thank you very much, Mr. Enan. Yes. Okay, so let's move to our next person. That is Mr. Muhammad Fadil Amri. So the title is chapter 2 of our technology engineering. So thanks.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Muhammad Milandi and I'm from Febriyani Indonesia, and I work on this paper with my teams that consists of 6 members that you can see on screen. And in this occasion, I would like to present my work with my team that's about optimizing and chatbot, the human and robot with multi-agent AI approach. Okay, next. So here's several things that cover in this discussion. It's from introduction, method, personal discussion, and finally I will wrap it up into a conclusion. Okay, so in customer service domain, chatbots frequently act as gatekeepers that serve the chat in the first layer. So every single chat that coming from the customer in the daily queries would be handled by bot first, and then when a certain criteria are met, then the chatbot decides to transfer it to the human agent. For example, you will see on the image on the right side. So here the example of conversation between user and bot. And for the normal conversation that could be easily handled by bot, we could label it as a normal chat. It's labeled on the red button. And when a certain criteria where in this case the user need help from the human, that the chatbot decide to hand out it to the customer service. And this specific case has faced several challenges, and one of them was how to optimize the timing of the handover decision. So we could optimize our operational efficiency, and but also we could maintain our customer relation experience. So when the chatbot decide to hang out earlier, then we sacrifice our operational efficiency because the human resource cost will be higher, and the average response time could be done because there might be a queue between customers. And if the chatbot decide to hang out lately, then it might make the customer experience become worse because at the time the customer might be go upset and frustrated, and it should be handled to the human. And not only that, when we develop this kind of model, we have another limitation about the public and specific datasets for evaluating the learning to human handover. Okay, next. So we introduced the ICADEIS dataset here. It was a dataset that consists of 100 dialogues between the customer and the agent, which consists of bot and the human agent. And this dataset was manually annotated by our 3 domain experts from the ICADEIS customer service team. And this dataset is a binary classification. So for every single utterance or chat, there was a column transferable that could be set to false when it was a normal chat, and it could be set to true when it was a transferable chat. And then this data is also strictly anonymized by replacing the personally identifiable information with the dummy data. So we could see on the table on the right side, there was the ICADEIS dataset statistics and the data structure. And we could see that this data is imbalanced because the transferable utterances here compose for about 86% of all the data. Okay, next. So the objectives of this research are two. The first one is to optimize the LLM to hand over human decision in the modern customer service platform, like our customer channel platform, and then to compare between the single agent and the multi-agent architecture here. Okay, next. So let's jump into the method. So you can see on the left side, it was image from the single agent architecture here. So you clearly see that there was a single agent in the green box that's named answer agent. So this single agent is responsible for all of the chatbot operation from the handling incoming message, give the routing decisions, and give the final response to the end customer. And on the right side, you could see a multi-agent architecture. So yeah, it's clear that the main difference here was the number of the agent, where in the multi-agent we have several more agents here that could handle specifically from the customer data extraction and then the routing, and 3 specific agent to respond to the final answer. And let's take a look on the customer data extraction agent. It was actually a node that consists of 3 more specific agent here that would help give a better data extraction. So our routing agent would give a better decision. Okay, next. And then for the experimental setup, both of our architecture using the COT or chain of graph prompting technique, and for the multi-agent, we also give another kind like role-based prompting there. And then I would like to emphasize more about the routing mechanism because it was critical here. And this routing agent for both of the agent is based on several factors. And the first one was the user emotion. So we evaluate the user emotion. Is the user angry or not? is the user confused or not, and any other information that could give a signal for our routing agent. And the next one is what user needs. So it's basically a user intention. So if is it only the casual routing? Is it complaining, or is it just exploration about the product and any other intention? And the last but not least, and it was very crucial to convert the customer to become our client. It was the business potential that identified by SVC or high value conversion score. So it's basically a score that we give to a certain criteria, and then all of the score would be total to become a HPC score. And then when this HPC score pass some threshold, then we could say that this chat is important and was transferable because it has to be handled by human as soon as possible. And when the score is below the threshold, then it was just a normal and our chatbot could handle it easily. And this experiment was conducted in the Kiskas Optional platform. And this model is evaluated using several metrics that works on our imbalance dataset. So the metrics like precision, recall, macroeconomic score, and the outflow. So on the right side, we could see on the table 3, it was the hyperparameter method from this experiment. So we use 2 architecture as I told before, the multi-agent and the single agent. And for the model, we use GPT 4.1 and Gemini 2.5 Flash. And for the other hyperparameter, we just use the default. So the temperature here we set to 0.7, the top P is set to the 1.0, and the max tokens is set to none, because we only focus on the prediction here. Okay, next. So from our experiment, we got this result. So on the upper table, we could see the evaluation metric result from our metrics here. And let's focus on the macroeconomic score because it was our primary metric here. We could clearly say that our multi-agent outperformed the single agent by having a higher score. And for the single agent Gemini, it has significantly improved by changing its architecture. It was almost double from the 0.3 to the 0.6. And for the OpenAI, we got a modest improvement, but it's still good because it was about 20%. And for the lower table, we could see that for a specific case, the multi-agent model is tend to handle easier than the single agent one. And it justifies why our multi-agent give a better result because it has a lower error rate. Okay, next. So for the multi-agent, it has a tendency to hand off area, and it is safer for our business because it reduces the inaccuracy because of our autonomous error. And however, this could impact back on our efficiency because it requests more higher human resource. But for the single agent, we could see that performance is heavily dependent on the foundation model here, because for the OpenAI model and the single agent got more 20% better score than the Gemini one, and it has tendency to be overconfident and fail to trigger when certain criteria are met. And from our experiment, we see that a complex and specialized architecture like the multi-agent could compensate the limitation of the smaller LLM models, like we see on the Gemini 2.5 that should be smaller than the GPT 4.1, but on the multi-agent variation, you could see that it could beat it, or at least came up with this level of GPT 4.1. Okay, next. So in conclusion, the first one, we see that multi-agent are proven to have more effective and more reliable to handle this complex customer service scenario. And this KCS dataset that I was presented before has the potential to become a benchmark to evaluate this kind of handover systems. And last but not least, architectural strategy play a more dominant role than LLM model size when a certain point. Like when our model is capable enough, then this multi-agent architecture could be better in performance. Okay, next. So in the video research, we could improve our model to adapt the dynamic handover policies like using reinforcement learning. So from the other studies, like Rehack, there was a model that has been presented and proven to give a better performance. And we also could improve our dataset to become more diversified and to improve this model generalization. So the ICADEIS dataset could become a more robust benchmark in future. Okay, I think that's all from my presentation. Thank you.
Okay, thank you very much, Mr. Mani. Okay, so we can move to start the Q&A session. Please, the question of audience.
Yeah, maybe I could try to ask a bit.
Okay.
Okay, so Mr. Mahadi, right? Yeah, once again, my name is Kevin from University of Indonesia. So, exactly what I want to ask is not about you are creating separate agent, right? Before you are transferring from one, let's say, customer A trying to ask something from A, so you will try to ask one agent first, and then the agent will proceed to the other things, right? But my question is, it's more or less maybe a bit outside from this, but do you considering the kind of prompt injection in here? Because usually, yeah, we know in Indonesia, especially, maybe I will take some example from the, Badan Gizi Nasional, then everyone try to test the prompt, right? That, okay, they are trying to do a prompt injection like, okay, my grandpa want to ask something because it creates some urgency, and usually the agent will, will do something that outside of the road that we already prepared. But maybe I will just want to ask like, do you already try to prepare it from the agent efforts or something like that?
Okay, thank you for the collaboration. Yeah, in Indonesia, we face several customer that very unique and we just try to inject the system. So yeah, we have already got a prompt injection agent before this system because the study only focusing on the routing decision. So we cut it, but we already tested it, and in the chatbot product, I think it's obligatory to could handle it because it might be very dangerous when the sprawl injection happens. Thank you for the question.
Okay, thank you so much.
Any question? Yeah. That's all? Okay, thank you very much, Mr. Mani. Please applause for Mr. Mani. Okay, so we move to the next presenter is Mr. Febriyani. And the title is about Indo words, the estimated analysis of the agent, yes, there are what policy using XGBoost and STG classifier.
Yes, so
The time is
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. My name is Dedi Gunawan. I'm from Universitas Muhammadiyah Surakarta, Department of Informative Engineering. So at this time, I'd like to present our research. The title is Interpretive Scientific Analysis of Indonesia US Data Transfer Policy using Exposed and SGP classifiers.
we bounce. Start. Yeah, sorry. Sorry. Okay, that's fine.
Okay, so today I'd like to present our research in the title is Interpretive Scientific Analysis of Indonesia US Data Transfer Policy using Exposed and SGP classifiers. Next please. So okay, this is the outline. It consists of 4 elements: introduction, methods, result in discussion, and last is conclusion. Okay, please. So in this section, why we do research in data transfer policy, because it was becoming hot issue, research specifically related to the economics problem, where Indonesian government willingly to share their data to US for the sake of, let's say, tariff export and economical issues. So yeah, for this concept, we are doing data scraping, and in this case, we scrape data from YouTube and TikTok, and yeah, it was very interesting because we found many comments from netizens, let's say, Indonesia recently, and yeah, based on these various information and various opinion, we would like to know the sentiment of people regarding to these issues, because it's very crucial, especially in cross-border data transfer, where actually to in handling data between Indonesia government and US government, maybe we have a different, let's say, different technique or different strategy. Next, please. So to handle this data, since the data is unstructured, because we have a lot of emoji, a lot of symbols, and many other things in the comments. So we use machine learning to handle and to process this data. And the machine learning that we use, we have Widia 3 hosting and Widia model that are already used in various studies, because its efficiency in interactive learning and scalability to large data sets. Okay, this is steps that we do in our research. Starting with data scraping from YouTube and TikTok comments, then we do data pre-processing, and then we conduct data labeling. In this data labeling process, initially we use automatic labeling, and then we verify using manual labeling. So we can say it is a semi-automatic labeling. After that, we extract the feature using interpreter and convert the text into tokens, and we generate 768 dimensional embedding vector. Following that, we split the data into 80% as a training and 20% as a data set. Okay, the next step is feature scaling, adjusting feature scale from data set. And then we put the data set into training model. We use XGBoost, then HD classifier. After that, we evaluate the model. We evaluate accuracy, precision, recall, and advanced code. And then we visualize in the code log, and we adopt the model into web application. Okay, so we do scraping from February 20 to March 2026. So yeah, it's about 1 month, and we put 5 keywords here: personal data transfer, Indonesian data sent to the US, data protection, and data privacy. So from the data scraping, we obtained 1,513 comments, and we already cleaned this and removing the data redundancy. So in total, we obtained 1,513 comments. Okay, so we do cleaning and then dashboarding for the data pre-processing. Yeah, we remove some emojis, tags, and specific characters, and then converting all the characters into consistent lowercase. Okay, so this is the result of labeling. This is the initial step. We use automatic labeling. From the automatic labeling, we obtain 38.5% as a positive, and then 61.5% as a negative. But following that, we test, not that, but we do manual labeling and we check it here from the automatic. And finally, we obtain only 16.8 positive and majority 83.2% negative. So in this case, we have a very unbalanced, because 83% is so much. Okay, so this is the picture extraction that we use converting the text to the embedding using per Indo per architecture. Okay, and then we use splitting data, 80% as a training, and then 20% for the testing of the total 1,513 data comments. Okay, this is the evaluation result. From this figure, we can say that accuracy of the SGD classifier slightly higher compared to the SG Boost, while the precision of the SG Boost is higher, while the other recall and advanced score SGD classifier get the higher result compared to the SG Boost. Okay, this is the conclusion metric of this two training model. Okay, now we move to the workload that says how the sentiment is formed from the comments. Most of the comment, the positive one more focus on benefits, and the negative one because most of them have trust issue, right, to the government and data sovereignty. So expressing stronger critics and distrust to this kind of regulation. Okay, the last step is we get the model and embed the model into web application. And this is the result. So user can type their comment and click to analyze whether the model can perform to detect whether the sentiment is positive and negative. Okay, conclusion. SGD classifier achieves higher accuracy, slightly higher compared to the SG Boost. And linear model does better by utilizing the word features on limited dataset because we only scrap dataset from 1 month because that time was the very long issue in that time related to this regulation. And we develop fast-paced web application to for users so that they can try to check whether the sentiment is negative or positive. For the future work, we're going to use aspect-based sentiment analysis with larger dataset and maybe with the different issue, specifically related to the data sovereignty of Indonesia. Okay, I think that's all for my presentation.
Thank you very much, Mr. Benny. So a question from our kids about their research. Okay.
Okay, hello. I would like sorry, my name is Febriyani. I'm from Discuss. On to ask you about the data set. you mentioned that before you use YouTube and TikTok like this, why didn't you use the X or Twitter also? Because I see that your mother used the introvert tweet or something like that.
Yes.
I just curious about that.
Yeah, actually, we also try to obtain information from X, but there is no much discussion on X and very limited. And people discuss much in YouTube because there is a video with the expressive people. So that I think because of the explanation on why we need this kind of data transfer and the effect of data transfer is explained using video with clearly and informative things. So people more attracted to that information on the video rather than discussion with them. Actually, that's the main issue.
Thank you.
So, any reason? Yes. Yeah. Thank you very much, Mr. David. Okay, let's pass it over to our next presenter. Please welcome Mr. Michael Kevin, new version of a paper titled LM at Language, a fixed language model cover for hosting knowledge and reconciliation in academic language.
But first of all, will you move the comment into the left side because I oh okay, so this is not the render. Will you download the renders? Because I submit a revision.
Yes.
Yeah, okay. And then remove access of the revision. Okay.
Wait a minute.
Yeah.
Coba coba linknya ya ya acara belum. Ini
Yes. Yeah.
yes
Okay. Good afternoon, everyone. So first of all, my name is Michael Kevin from Universitas Indonesia. So I would like to present about our finding and our works about VLM image, a vision language model framework for cross-domain matching and reconciliation in accounts payable. So the work itself is under supervision with my supervisor, Professor Dodi Sudiana, and actually, if you want to try about the framework or the workflow itself, you will scan the demo app on the top right. I will put all the QR in all my slides, so later when I'm presenting, you can still scan it. Okay, maybe we can go next. Yeah, more or less the content itself is all the same with the others, so I will just go with the introduction. Okay, and go next. Okay, so for the introduction, actually, what is account payable, and let's say we would like to say the reconciliation. So usually, when you are in finance accounting, when you have to pay a vendor, like let's say you are buying something from a vendor, and then in this case you are buying a drinking water, and usually the vendor itself will send some invoice to the buying company. And one of the tasks from the AP itself is a department that are paying the vendor. But the first thing that they should have to do is to do some reconciliation. So some kind of one of it is cross-checking between some payment documents such as invoice, receipt, tax invoice, delivery notes, and many other Indonesian AP document. That is vary in so many format and language, which we have some challenge here, like mixed Indonesian and English text, and that's the other things is every invoice have a diverse layout from each vendor, and then the title itself, let's say sometimes it's called sales invoice, and then nota berjualan or tagihan or many others Indonesian name. So I want that there are some gap here. Usually the VLM to extract this document is only until extraction. So it still has some gap in the reconciliation process or with the cross matching between documents, something like that. So here I propose some three risk equation. Like the first one is could the LLM extract correctly and classify the data from the Indonesian AP document, and then come to the next question is how could we match each document to each other, like using some identical semantics. So this is some kind of the sentence transformer, matching between the line item. And the last one is could the LLM based on the match report could give some recommendation based on real with the AP official judgment. So is it the same or not? Okay, we can go to the next slide. Okay, it's okay. Okay, again. So this is more or less the pipeline itself. So the vendor usually submits some document into the website, right? And then the scanned document will be first classified by the VLM or the LLM using zero shift setting, and it will classify it into one of these four document type, because by considering by this one of these four document type, it will next give some prompt into the next extraction agent here to extract the JSON format, and then after it's already extract the JSON from each document, each JSON will be compared in the queue will be compared to each other in the module 3, the 3-mode matching engine, and finally it will produce some match report that will be set decision, produce approve or reject recommendation. So everything I use Open Operator API here to do the VLM access here. Okay, thanks. Maybe. And the method itself, this is for the module 3. So in the module 3 itself, because there are different kind of document here, it has several modes such as comparing quantity, or for this invoice to invoice, we compare it by the name of the line item. Okay, maybe we will just go next. Here for the data set itself, I use real operational AP data from a private Indonesian retail group. And for the purchases itself is from purchase of drinking water, so still one commodity here. And it's consists of 139 documents with 28 transactions across with 8 different vendor tiers. And there are only 4 types here. And I compared the extraction with some ground truth annotated label. And for the decision is also compared to the ground truth of the how the AP officer reject or not. Okay, next. And based on the result itself, for a simple test like such as classification, the GPT-4o, I use 4 model here. So this is GPT-4o, Cloud Sonnet 4, Gemini 2.5 Flash, and last one is the Qwen 2.5 with the 72 billion complexity variable. Okay, so For simple tests such as classification, the GPT achieve perfect accuracy. So it will, with the prompt that I put to classify the document, when I put an invoice, it's correctly classified as invoice and etc. But for the podcast, there are so many misleading surat jalan as invoice. So that's why the accuracy result is the lowest in this case. I don't know whether the frontier model will solve this, but I haven't tested it. But for the extraction, there's one of the paper that I use as reference. Gemini is also come as the best extraction in my case here, which achieve until 90.5% accuracy. Okay, maybe we could go next. And for the matching itself, because I try to compare between, let's say invoice line item into the text invoice. If you only compare it by exact or some quasi matching between the two line item, it still only give around with the perfect extraction, only around 20% of the line item is being matched correctly. But if you use semantic matching here, it could increase they already know that, oh, okay, this line item is more or less the same with this line item until with the Gemini extension, it achieved 44% of the line item matching is considered to be the same, something like that. Okay, more or less like this, and then let's go to the next one. But in the decision agreement itself, it's still biased into more reject. Based on what I have checked, here, if we can see, most of them based on the prompt that I created, which later I could you could test it yourself. Most of them is being bias rejected. And like from the 28 transaction, 15 of entered in reject. If we check it, like accuracy 50 is only when you only already set it as everything to be approved, even that is have more accuracy than the baseline of the ICADEIS model. So GPT-4o is going, it's better, but still biased. So, but later, okay, later is okay, next. But later it is fun because one of the problem is not only the prompt, but also the match report that I supply to the summarization agent, because the business logic itself, sometimes the text invoice value is not the same as the receipt, because we have to check the transaction as a whole. Like, let's say when you have a receipt of 1 million rupiah, the text invoice, sometimes the vendor release for text invoice that consists of 250 each. That's why when we use the first matching report, it says there are 4 different total in like each match for each document. But because in the redefined diagnosis here, when I try to fix it, when to check the value as whole, it will check that, oh, okay, so this is not a total difference. Okay, next one. So in conclusion, for a simple test, we successfully produced a end-to-end VLM pipeline for cross-document API reconciliation here. Although this is still a preliminary study, but it already shows some results which we can improve better in the future. And for the simple tests such as classification and extraction, the VLM is already good enough to do it. But for the reconciliation, it still needs some adjustment. And for the future work, based on the reviewer feedback, we will do some extraction through fine tuning, domain adaptive prompting, and retrieval augmented approaches to reveal error that bottleneck the downstream matching. And then the next one is implementation of aggregation aware matching for the wall versus part artifact, and also some kind of two-step matching. So you are not directly compare one document to each other in one iteration, but maybe you have to make a two-step, like comparing invoice to PC first and then invoice to text invoice, like you have to split it. And of course, a larger multi-vendor dataset to check whether the algorithm itself will be generalized or not. Okay, next, more or less that's from my presentation and our work and finding. If you have any question and discussion, you will ask. And the demo app itself has some review password, right? You can put this UE.stream ICADEIS 2026 for the your referral password if you want to try the one. I only limited 50 call per day, so yeah, it's okay if you want to use it. Okay, I guess that's all from me.
Give you a plus to listener. Okay. From the audience, any question, discussion? Okay. So from Mr. Fabio.
I think maybe we start with.
Yes.
I'd like to ask a short question here. So the first one, I see that you use Gemini 2.5.
Yes.
Why didn't you compare it to the Pro version? Because I think the Pro is a big model. And the second one, it was about the data safety. Because as far as I know, I'm not sure right now, but when I was just take a look on the safety, I think the only provider that commit to give data privacy was only the Azure, and you use the alternative. Is it okay or yeah? I think
Yeah, okay. Yeah, but again, it depends on the internal because I'm using an internal data set here. But yeah, for your information itself, we are using Gemini and Google Workspace in our work. So that's why, yeah, I think for the Gemini case, it's usually more or less still okay. But yeah, I already also injected into 300 kind of model, right? But because this is only a small data set, yeah, just for the sake of testing and experiment, it's still okay with the impact of only drinking water, like around 15,000 rupiah per gallon water. Yeah, it's still okay more or less. And back again, the question itself is why not comparing with the Pro? It's because of course the first one is yeah, of course cost usage. Yeah, yeah, the cost of using the Gemini 2.45 Flash is of course cheaper than the 2.5 Pro. So I haven't compared it yet, but I tried once case in that I compared 2.5 Flash with the 3.5. So there's some kind of case that I found while checking the document. It showed that in operational data, sometimes the delivery note is written 3, but sometimes in operational, yeah, okay, I sent 4, so I just select the number 3 and then I put 4 beside handwritten. And 4 of the model that I tested here, it's all written quantity as 84. Even if I put some kind of rule that if you put some, see some handwritten number, use the handwritten one. If you see some slash in the other quantity. From for the model is yeah, the rule didn't work, but in 3.5 plus it correctly detect okay, so the quantity is 1. But I guess in better model it will understand the problem correctly.
Okay, thank you very much.
Yeah.
Good. Yeah. Any question? Okay, but the time is up.
Okay.
Yeah, thank you very much. Okay. Yeah. If you can, for the discussion, yeah. Okay, the last one is Mr. Faris Rifki. And the title is about the design enterprise architecture deadline for intelligent asset consumer and review mechanism in most shop operation. So the title starts. See.
So, good afternoon, everyone.
You want? Where is it?
Is it right?
Oh, wait. Wait, yeah. Jadi sebelum ini. Sorry.
It's all right.
Wait.
What's it? So this one?
Okay, so good afternoon, everyone. Today, I want to present our research title of designing enterprise architectural designs for intelligent asset appraisal and product recognition in financial communication. And on behalf of my co-authors, Mr. Iqbal Mukti and Sabara Katasa, today I will be the presenter for this paper. Okay, so this is our content list. First, we're going to talk about the introduction, the method, the result of discussion, and the last one is the conclusion. Okay, so pawn shop. Pawn shop is a financial institution that provides short-term collateral credit loans using movable assets such as gold, jewelry, electronics, and vehicles. This serves as an instrument for financial inclusion, particularly among lower-income population who lack access to conventional banking. In other words, pawn shop is a place where you trade your asset for like an easy cash. So there are some challenges that pawn shop face in day-to-day basis. For example, like the asset appraisal still relies on the individual appraiser judgment. This is probably the most general problem that are in the pawn shop business. And the next challenges are probably more related to the big company like corporation like in Indonesia, example like PT Widia, where the customer data is connected across transaction, summary, and digital channel. So, what are the impact on their business? The first is the inconsistent valuation across the branches. These are resulted by the individual appraisal judgment, and also the resultant in mis-cross-selling opportunities and reduced institutional revenue caused by the disconnected and fragmented customer data across different channels. And so the study proposed the enterprise architectural guidelines for integrating AI into pawn shop asset appraisal and product recognition process. Next. So, furthermore, existing AI lending studies concentrate heavily on real estate and mortgage market. And also, movable asset lending and pawn shop operation remain substantially under research. Also, current studies focus predominantly on algorithmic solution without covering the organizational and governance frameworks needed for an enterprise-scale AI integration in regulated financial institution. So, our objective today is to analyze the systematic operational challenges in asset appraisal and fragmented product recognition. Also, design a generalized enterprise architectural guidelines that integrates AI into pawn shop operation. And also, we evaluate the proposed framework against the industry operational objectives and financial regulatory requirements. Next. Okay, so the methods that we are using for this paper today are the DSR, or the Design Science Research Framework. So this framework follows 4 stages, which is the problem identification, defining objectives for solution, design and development. On this stage, we are utilizing TOGAF AEM from phase A until G, and also demonstration and evaluation stage. In this stage, we conduct an FG with a domain expert from pawn shop institution, and we take those input and we quantify it via ICADEIS on a 4-point different scale to measure the consensus. And also, we use SLR as our suitably adapted guidelines, and we collect that from various databases, and this links us with 31 articles that we use to extract and map the components across the business, application, and technology layers. Next. So, this is the motivational diagram. So, the motivational establishes the strategic foundation by aligning the stakeholder consent with the primary business goals. It also demonstrates how the drivers, like, for example, the operational efficiency and the revenue and the customer satisfaction, are necessary and intelligent digital platform and ensuring all technical development is driven. And as you can see in the image here, our stakeholder are the asset appraiser, the customer service officer, and the customer himself. And what are the drivers? For example, like the asset appraiser, the driver are the operational efficiency. What are the problems that the asset appraiser face, which is the inefficient and inconsistent manual appraisal process? And what are the goals? Are to improve the appraisal accuracy and operational speed. And how do we resolve these goals? By designing the intelligent asset appraisal. This intelligent asset appraisal has a requirement, which is the system shall provide automated intelligent asset appraisal and also shall ensure a transparent, auditable valuation decision. And also for the customer service officer, as you can see, the drivers are the revenue and the customer satisfaction. And the problems are the disconnected and generic product offerings that received by the customer. And how do we realize these goals for the customer service officer by integrating the intelligent product recognition. And yeah, as you can see, the system shall consolidate customer data from all the touch point, and the system shall generate a personalized product recognition. Okay, so this is the realization of the diagram. This diagram illustrates how the motivational objectives that we already mentioned before are technically executed through a modular multi-layer architecture. So this one, as you can see in this image right here, the top one is the requirement that we already said before, the diagram, and the yellow box right here is shown to be the business process that are the concept industries, and how do we realize this business process by integrating the application layer. This application layer, we propose a digital intelligence platform where there are in the digital platform there are two systems, which is the automated process system that used to realize the collateral collection business process. Also, the intelligent recognition system are used to realize the customer engagement on the product recognition process. So these two systems are structurally bridged by a shared function AI analytical engine. And in this green box right here is the technological layer, which is the physical layer that support all of the layer above it. And as you can see in here, there are mobile device and office desktop workstation, and they can access this platform via web browser and also connected to the cloud server. And as you can see, we got feedback from our expert FGD resulted in architectural refinement when we added a device that is stickable. Why we added this device that is stickable? It is because the asset appraiser itself, mainly in the system, the asset appraiser capture the image, and then the AI will give the estimation of how much this asset will cost. And the reason why we choose the device like this too, because not all of asset can be valued, but only the image itself. So, for example, like we need to evaluate the smartphone. You cannot just take a picture of the smartphone and evaluate the price itself. You should know the inside of the smartphone too. And so why that's we edit the device that is cool. So this is our expert validation result. The proposed architectural guidelines were evaluated through a focus group discussion involving 5 domain experts from Data Pegadaian as our case study that representing the workshop industries. As you can see on this table right here, the quantitative validation did a perfect item content validity index score of 1 across all evaluation items, which is divided into 4 different variables: the relevance, completeness, understandability, visibility, and is achieving an overall score consensus score of 1. So the conclusion: the study addressed the systematic challenges of generative collateral appraisal and fragmented data by delivering a modular AI integrated digital intelligence platform. When validated through an expert focus group, that we got a perfect one ICADEIS score that confirms that these architectural guidelines are structurally complete, relevant, and highly visible. Ultimately, the resulting framework provides a standardized foundation that successfully embeds the compliance, auditable valuation decision, and personalized customer engagement directly into regulated financial workflows. And for our future research, maybe we need to evaluate the life prediction implementation of this architectural framework to track the real-world performance under active operational workloads and explore the transferability and adaptability of these modular guidelines across more collateral client or different financial sector. And also extend the applicability to financial technologies industries beyond traditional financial operation. Okay, I think that's all from me. Thank you so much.
Thank you, Mr. Paris, for hosting our presentation. Yeah, it's insightful topic. Any question from our audience? Yeah. Okay. So question from me. Okay. So which you have worked on all this enterprise architecture deadline accommodated with AI in advancement without requiring command of hold and also so all of the bodies the existing and also targeting AI and algorithm with AI.
Okay, so maybe we already creating the business process before and after we implementing this digital intelligence platform, and mostly the impactful business process are the asset appraiser itself. Because before we implementing this digital intelligence platform, theoretically, the asset appraiser still need to check whether this asset right here is non-gold or not, and also they have to manually check the model of the asset. For example, like they appraise a smartphone, so they have to know what kind of smartphone is that and what year that the smartphone release. And after we implement this digital intelligence platform, the asset appraiser can just take a picture of the smartphone and plug in the internal diagnostic tool and to get the more fully data that the AI has been had. And so the asset appraiser can be more better to keep the evidence.
Okay, thank you very much, Mr. Maris. So we can okay. Thank you very much. Okay, so ladies and gentlemen, this concludes the presentation on the hobby Chinese 2026. I would like to thank you for all center for the external contribution and insight. So I would also extend my gratitude to all personnel for the engagement to the program Widia. So we hope this session has been both informative and so inspiring. Thank you once again and have a good day. Thank you. Assalamualaikum warahmatullahi wabarakatuh. So we can talk together. Oh, sorry. So we. Ya, kita foto bersama dulu. Ya, kita foto bersama dulu di sini ya. Ini mau digeser atau biarin aja? Bisa kok. Aman ya?
Iya. Gimana?
Ya, ke sini kita. Ada berdiri. Ya, ada putih. Saya jadi dua rows gitu dalam slide yang seperti ini. Jadi apa? Jadi lagi. Oh.
Satu, dua, tiga.
So freestyle tuh.
Bisa,
Gimana ya?
ini kagak ada dari Talsumnya mau gaya apa?
Ya udah, tadi kayak gini tuh namanya harmoni.
Oh iya, masih kan?
Ada harmoni extra seperti ini.
Oke, iya.
Ya, harmoni.
Harmoni.
Oke, oke, excellent.
Biasa ya.
Oke ya. Integrity. Apa tuh, Pak?
Oke, thank you very much. Biasa. semuanya kan gitu kayaknya nggak mungkin offline gitu.
Analysis.